Hello, good morning, good afternoon, good evening to you out there wherever you are in the world. This is Samuel Aneka and welcome you to this Samuel Educators channel. So we this is part 2 of our lesson on density. In our previous lesson we looked at density. That was the introductory lesson. So I explained the concept of density and I gave you the formula used to calculate density and as well as the unit to calculate density. We went further. I explained how you could actually obtain the density of a regular shape object. So I told you that in our next lesson we're going to be looking at how you can actually calculate the density of an irregular shape object. So that is what we'll be looking at today. But before I go ahead, if you know you're not subscribed to this channel, I would like you to go ahead and quickly hit the subscribe button and click on the bell icon so that you always be notified whenever I upload a new video. Click on it and set it to all, and also hit the like button. At the end of the day, when after this lesson is over, I know you're going to enjoy it. Just write your comment whether you like the video or there's ways we can actually improve, and we are going to answer you. We're going to do what you ask us to do. So today, like I said, we will look at how you can obtain the density of an irregular shaped object such as a stone. So let's assume you have a stone. Now a stone is not an irregular shape. It can't approximate a cylinder, it can't approximate a sphere, it can't approximate a cube, a cuboid, a prism or anything. So how do you get the volume? Because you won't be able to measure the diameter, you won't be able to measure the length and all that. So how do you obtain the volume of that stone? So we're going to use an indirect method. There are two methods we can use. We can use a measuring cylinder or an Eureka can or overflow vessel. So the first one we're going to explain is how to use a measuring cylinder. So you get the following materials or slash apparatus. You're going to get the stone which you'll be using. You want to find the density of the stone. You're going to get that stone. Get a string, water, measuring cylinder, chemical beam balance. So the stone, now you need to find the mass of the stone. So you get the mass of the stone using the chemical beam balance. So from the chemical beam balance, you get the mass of the stone. You weigh the stone on the chemical beam balance and obtain the mass and record it down. So you now have a value for mass. So record that as M. So now next you need the volume of that stone now. So you will fill the measuring cylinder up to a certain level, let's say halfway, and take note of that volume. Call that V1. Volume V1. That is the initial volume. Let's call that V1. Then you will now tie the stone using the string and gently drop the stone into the measuring cylinder till it submerges in the water. So when it submerges in the water, you discover that the water level will rise in the cylinder because the stone will actually displace some water. So you now, when the water has stabilized, it's now stable, you will measure the new volume now and call that V2. So you have final volume V2. So how do you get the volume of the stone? The volume of the stone now is V2 minus V1. That is final volume minus initial volume. That value will give you the volume of the stone. So from there now, you've already measured the mass of the stone using the chemical beam balance. Now you've gotten the volume V2 minus V1. So to get the density is going to be mass over volume. The mass gotten from the chemical beam balance divided by the volume gotten from subtraction of V2 minus V1. So that is just that. That will give you the density. This is using the measuring cylinder approach. Okay. So let's assume if the final volume was 25 and the initial volume was 15. 25 minus 15 gives you 10. So the volume of the stone is 10 cubic centimeter. So now we'll now proceed to how you can use an Eureka vessel to get the volume of this stone. Okay, so we'll now move ahead to that method 2 using a Eureka vessel or overflow displacement can. So let's go to that method now. So this is our Eureka vessel. This is our Eureka vessel. So still using the same material. Now we have, in place of the we're going to have a measuring cylinder as well. Then you add Eureka vessel. This is the Eureka vessel. So you fill it to this level. Definitely any water that goes above this level is going to pour out. So you fill it to this level, the highest level. When you fill the water to this highest level, next, with a stone tied to the string, you will drop it gently into this vessel, and you keep your beaker. You keep a beaker here. As you are dropping the stone, as the stone enters into the water in the Eureka vessel, there will be a displacement of water. So as the stone is displacing water, that water will pour into this beaker. As it's pouring out, you collect in this beaker. So after collecting the water in this beaker, you turn into a measuring cylinder and measure the volume. So the volume you get from the measuring cylinder is the volume of the stone. So still the same way, using the chemical beam balance, you use the chemical beam balance to get the mass of the stone. So you are going to use the chemical beam balance to get the mass of a stone. And still using this formula, you get the density, mass divided by volume. The mass gotten from the chemical beam balance divided by the volume of overflow water that poured out from your crab vessel into the beaker, which you now measure in the measuring cylinder. So those are just the two methods you can use when the solid is irregular. So you can do that. So I would like to give you an assignment. Now, supposing you want to find the volume of your body. We know that human beings, our body is irregular. There's no how we can measure the length, our height, and our width, and actually ascertain our volume. So how are you going to get the volume of your body? I want you to brainstorm, and you can supply the answers in the comment section. Okay, so with this, actually we've come to the lesson for today. In case you are not subscribed to this channel, please hurriedly hit the subscribe button and like the video and drop your comment as well, and click on the bell icon, set it to all, so that you always be notified whenever I upload a new video. Thank you, bye, and join us in our next lesson. So in our next lesson, we are actually going to create some calculation on density. So watch out for the next lesson. Bye. Thanks so much.